So EES, the full form of EES is engineering equation solver. So this was not meant to be used just for solving thermodynamics problem or just for solving mechanical engineering problems per se. It was developed as a solver for simultaneous equations. And since it found many applications in engineering field, so hence it was named as engineering equation solvers. So it can solve differential equations, it can solve linear equations, even nonlinear equations. So it is a simultaneous equation solver. Now the developer of this software has actually included many important or useful tools to this solver. So in the basic form, you can just see the what I was meaning by engineering equation solver. If you have two simultaneous equations, 2 into x minus 3 into y equals to 10, you go to calculate, solve. Okay, it will solve this set of equations. Okay, and it will return the values. This is what this software does. Now, in engineering applications, you can have multiple components, and each component could be described by a different set of differential equation or a linear equation, and then you will have to solve all those equations simultaneously to model the entire system. So this is what this software was meant for. So then the developer of this software realized that why not give the important things like fluid properties, okay, be it thermodynamic properties, be it properties like thermal conductivity, viscosity, all those things as a part of this software itself. So that is where this becomes a very powerful tool for thermal engineers. So if you go to the options and go to function info, and you will see that it has huge number of inbuilt functions. Okay, what we would be interested is this thermophysical properties. And even in these thermophysical properties, you can see there are several properties which are listed out here. Let me see. Are you able to see this?
Yes, sir.
Yes, sir.
Okay. So there are a lot of properties which are listed out here, and a lot of fluids which are listed out in the right hand side column. So you have all the refrigerants also. Most of the refrigerants are listed out here. It also includes these new refrigerants, okay, which are probably started. People have started researching about them maybe 5 or 6 years ago only. Even those properties are already listed. So the developer is continuously searching for research papers and getting the data and incorporating it as a function of in a function form into this software. Yeah, so the developer is actively involved in the connection of the database from your steam tables or refrigerant tables or whatever is available in the research paper or textbook into this software. So let's say you want to call the enthalpy of water vapor at a particular pressure and temperature. So what you can do is you can, let's say, assign a variable and you just call the function, the internal function. The command is enthalpy. First you write the fluid name, then you write the two properties. So this is the syntax. Okay, so if you write P equals to 100 and let's say T equals to 30, so it will return the enthalpy of water at pressure equals to 100 kPa. Now what is the unit? You go to unit system, you will see the default units are for pressure 100 and for temperature Celsius. Okay, so it will read P equals to 100. So this variable name is again fixed. You cannot use any other variable name over here. So as soon as you write P, it understands pressure. As soon as you write T, it understands temperature. Okay, and from where do you see this syntax? You go to the options function info, go to the enthalpy function, you will get the entire syntax over here. Okay, in fact, you can also choose the fluid from here, and it will place the entire form of the equation that you have to write. So here it is written as T equals to T and P equals to P. So you have to understand that this is an internal command T, which is associated with temperature. This is an internal command actually P, which is associated with pressure. And this right hand side T and right hand side P is a user defined variable. So instead of writing P equals to 100 and T equals to 30, let's see what it returns. It will return the enthalpy. The units would be in kilojoules per kg, that is the SI unit. You can also define this pressure as a variable. So let me write this as P equals to 100 over here, and T, or let's not confuse you guys, let's call this as A and B. I can write P equals to A and T equals to B, and then solve. Okay, now you see the advantage of using this. So I can make this as a floating variable, or I can create an array of A and continuously change the value of A and see the plot. That is what it can do. Or let's say I give you a problem and you solve it, and later on you realize that, okay, the problem I missed that the pressure was not 100, it was supposed to be 120 kPa. If it is assigned as a variable, you can just simply change the variable over here, the value over here, and it will give you the modified result. So it's a very, very powerful tool. And while showing you or demonstrating you certain things which happen in the refrigeration system, I also can use this for the simulation purpose. I can simulate the actual scenario over here and show you that, okay, power consumption reduces or increases in certain scenarios, COP increases or reduces in certain scenarios. So it's a very, very powerful simulation tool. It's a very, very powerful teaching learning tool also. In the other way, I would have asked you, okay, at T equals to 30 and P equals to 100, look for the property in the chart or the table. And then I ask you, now look for the same property at T equals to 10 and P equals to, let's say, 50 kPa, and tell me the difference. So it will take a lot of time. It will take maybe now 20-30 minutes to look for the property and take the difference and understand why or how it is changing. Whereas using this tool, it is going to be very easy for me to show you that how a particular property changes and how it changes the other system parameters. Okay, so a hand for using EES is going to be helpful. It will be helpful not only for your classroom environment, can be helpful for even your future work. It could be your BTP, it could be your MTP. So just install this EES software and just play around with this. See the options available. On YouTube, there are a lot of videos available on how to create a table, how to plot. Okay, I will also be showing you certain features as I move along while I'm discussing some examples. But I will not be able to dedicate time within the class period to teach you all the nitty-gritties of the software, but it is not very difficult. And the best part of the solver is you need not follow a sequential way of writing the code. Okay, it is not that you have to define your variables above and then only you can use it. That's the best part. You can define your variables later. Okay, similarly, you can write your any equation anywhere in the entire code. So let's say you have to find the difference between the two enthalpies. So let's give some values, A1 here, B1 here. Let's call it as enthalpy 1. And then I realize, oh, I need to also find out the enthalpies at certain other pressure temperature. So I can give it as A2 and T equals to B2. And then I define A2 and B2 below it, or I can define A2 and B2 even above the entire code. Anywhere you write, it is immaterial. It will solve. So since it is a simultaneous equation solver, it reads the entire code and then solves the problem. So writing the code in this is very, very simple. And since we are going to deal with only thermodynamic functions, so the syntax is also very, very simple. It would be very useful for the psychrometric processes also, even though charts I will teach, because with charts you can visualize the processes. But while solving, you will see getting the data from the chart is quite tedious. So that is where this tool can be helpful. Okay, so what I will be doing is a mix and match of chart and the EES. So in order to get the numerical values, we will take help of EES. In order to understand or visualize the processes, we will take help of the charts.